Hello everybody, this is Mr. Joseph. I'm going to be going through these problems with you. I would recommend trying a lot of these on your own. However, I'm just going to go through every single one of these as well so you can go back and kind of check your work. So the first one is sine of theta equals cosine of theta tan of theta. So looking at this problem, you pick one side and you just pick the side that is normally easier to work with. So looking at this problem, I believe that this side is easier to work with. So looking at cosine and tangent, I see that these are both multiplied, and my end game is I want to get a sine. So the first thing I'm going to do is, instead of writing tangent, I'm going to write sine over cosine. Normally having things in terms of sine and cosine will make your life a little easier. And because I'm multiplying here, we can cross out the cosines, and you see that we get sine, and the problem is done. All right, we move on to number 2. Once again, I think the left side is a little easier to work with. There's more action here, and our goal is to get 1 over cosine. So one thing I like to do a lot is I like to write division like side to side. And I see that there's a tangent again, so I think it'll be cool to write it in terms of sine and cosine. And now, this is the part you got to remember. So you're dividing fractions, and whenever you divide fractions, you need to multiply by the reciprocal. And then when you multiply fractions, you multiply across. And then sine divided by sine is just the number 1. And once again, you see that we have the same results. All right. Number 3. All right. So for number 3, I'm going to pick this side, and I'll kind of explain a little bit why. So I know that on the right side, there's only cosines. So when I saw this sine, I kind of got suspicious, and I'm just like, okay, I think I can do this problem pretty easily if I can make this sine in terms of cosine. So I'm just going to go on the side and kind of write an identity that we should always remember. And it's this identity right here. That sine squared plus cosine squared equals 1. So looking at this, I know that I can rewrite sine squared as 1 minus cosine squared of theta. So knowing that I have this, I can go here and I can write 1 minus cosine squared of theta. And then I still have this right here that I'm just going to drop down. And now I have everything in terms of cosines. And if you have like a negative cosine squared and you're subtracting another cosine squared, think of it as like -1 minus 1. -1 minus 1 is -2. So negative cosine squared minus negative cosine squared is going to be -2 cosine squared, which is exactly the same thing as what we wanted. So, a little weird, but do you see how this identity right here and like manipulating this can definitely make your life a lot easier. So let's try 4. All right, so number 4, we have this statement right here. So this statement, you should be a little suspicious because tangent squared plus 1 equals cosecant squared. And if you forget how we get this identity, I'll show you. So everything goes back to this. And then I don't know if you remember, but if you divide everything by cosine squared, you should have saw tangent squared plus 1 equals 1 over cosine squared of theta. So without even really doing any work, I mean, you can just write 1 over cosine squared equals 1 over cosine squared. And that's just simply using the fact. The fact is normally tangent squared plus 1 equals cosecant squared. Sorry, not cosecant squared. Secant squared. But secant squared means 1 over cosine squared. So that one was really nice, and that's why you have to be a little suspicious. Tangent squared plus 1. Okay, that's secant squared. Secant squared is 1 over cosine squared. There's like some relationship that exists. All right, number 5. Once again, this side kind of looks fun. There's like a tangent. There's probably some multiplication that can happen here that will help us get something squared. So I'm just going to start with the right side. Once again, you just have to try something, and like I haven't done this in a while, so I could be wrong, but I just looked at this side and it looked doable. So I'm like, okay. So we got sine times cosine times sine over cosine. You can think of all of these as having an over 1 and then multiply across. So you get sine squared of theta cosine of theta over cosine of theta. The cosines cross out and you get sine squared of theta. And we know that the identity sine squared plus cosine squared equals 1. So if we rewrite this, we can write 1 minus cosine squared, which matches what we wanted. All right, 6. Once again, we're going to mess with the side that has some more terms. So here I see a tangent squared and a cosine squared. So a lot of times people want to use the Pythagorean identities, but what I would say here is, once again, on the right side is a sine squared. So if all I have is sine squared, I probably just want to like keep everything in terms of sine and cosine. So I'm going to do cosine squared of theta times sine squared of theta over cosine squared of theta. And you can see as you multiply across, that the cosine squares cross out, and you get the same thing. It's really kind. All right, number 7. We're almost halfway there. You can definitely see that we're going to have to work on this side. So the first thing I notice is I see a sine times of tangent. So I'm just going to go ahead and like take care of that and see what happens. So once again, I'm multiplying fractions, so I multiply across. So I get sine squared of theta over cosine plus cosine. So what you need to think about in this moment is we are adding 2 fractions. So I know the cosine on the right side did not have a number under it, and the cosine I'm referring to, everybody, is this right here. Even though it doesn't appear to be a fraction, do you see how I put it over 1? And now we have a fraction. So what we want to do is you want to make it the same denominator. So I'm going to multiply this fraction by cosine of theta. And you get sine squared of theta over cosine plus cosine squared of theta over cosine. And because we're adding fractions and we have the same denominator, we can write it as a singular fraction. And then sine squared plus cosine squared is an identity, and we should know that that equals 1. And I believe, once again, that we get the same answer. All right, number 8. All right. Looking at this problem, I'm going to highlight this part first. We're going to be working on the left side, but I'm highlighting this part because I am curious to see like what would happen when I divide these. So I'm just going to write tangent squared divided by sine squared. We still have the minus 1, but I'm only going to focus on tangent squared divided by sine squared first. And tangent squared is going to be sine squared over cosine squared times 1 over sine squared. And we still have that minus 1. And now I get sine squared over cosine squared sine squared minus 1. The sine squares will divide out. And I get 1 over cosine squared minus 1. Let me go back and ask myself, what is my goal? My goal is to make a tangent squared, so I just reminded myself. All right. I'm going to scroll back down. I see 1 over cosine squared, and I believe that is secant squared. And then earlier, I don't know if y'all remember, we had, where is it? We had this right here. So I'm just going to copy it. Go down back to where it was. And does everybody see that I had tangent squared plus 1 equals secant squared as an identity? So if I rewrote this, tangent squared of theta equals secant squared of theta minus 1. So this is equivalent to tangent squared of theta, which is what we wanted. And that one worked out pretty nice. Number 9. So this part right here, everybody, is an identity, and we just kind of just talked about it once again over here. Do we see that tangent squared plus 1 equals secant squared? So I'm just going to come over here, and I'm going to write cosine squared times secant squared. And then secant is a reciprocal of cosine. And do you see how we get cosine squared over cosine squared, which just equals 1. So once again, seeing the 1 plus tangent squared, it was very convenient to use the Pythagorean identity for this one. All right, number 10. Once again, number 10 is really nice because tangent squared plus 1 equals secant squared. And then secant squared is just 1 over cosine. So this one was pretty similar to number 9. Just looks just a little different. But we get the same thing. Number 11. For this problem, you can start on either side. Once again, I'm going to highlight this side because I just like taking this cosine squared part and rewriting it in terms of sine, because everything on this side is all sine. So that makes me want to rewrite cosine squared in terms of sine. But there is something like interesting about this one. When you have this minus sign, everybody, whenever you replace the cosine squared, make sure that you put it in parentheses because that negative sign will distribute. Hopefully we remember that this statement equals 1. And then if we solve for cosine squared, that equals 1 minus sinus squared. So I'm going to take that and put it in place of the cosine squared. Then I'm going to take the negative sign and distribute. Highlight my like terms. If I have one sine squared and I add another sine squared, that means I have the pleasure of having two sine squares, and then I'm subtracting the 1, which is exactly the same thing as that. All right, number 12. So once again, I'm going to pick the side that has both cosine and sine because this side is all cosine. So I want to rewrite in terms of cosine. And once again, I know that sine squared plus cosine squared equals 1. So sine squared equals 1 minus cosine squared. So I'm going to get 2 cosine squared of theta plus 1 minus cosine squared. And these are like terms. So if I have 2 cosine squares and I'm subtracting 1 cosine squared, that means that I only have 1 cosine squared, and I still have the plus 1. And these now match. All right, 13. All right, this one is interesting, like which side we should start on. What I would say, I think because these two are subtracting, it makes me feel like I want to start on this side because most likely I'm going to have to subtract them, make fractions, make the same denominator, and it'll eventually be something where it'll end up multiplying. But normally when you're subtracting these two, it's normally nice to think about like making fractions. So there might be more than one way to do this, and I always tell this to people, like, please like try something and see how it goes. There's multiple ways to do it. But from my perspective, I just really like taking tangent squared and making it sine squared over cosine squared and subtracting it by sine squared. I want it to have the same denominator. So I multiply the second fraction by cosine squared. And I'm going to end up with cosine squared on the bottom. I'm going to have sine squared minus sine squared theta cosine squared theta. And I know you're wondering, like, how can I use this information? You got me subtracting two things that are not even the same terms. But this is when I tell people my favorite 3-letter word. It is called GCF. What does this and this both have in common? They both have sine squared in common. So what I'm going to do is I'm going to factor out a sine squared. And you're going to get 1 minus cosine squared of theta over cosine squared of theta. And another thing is, everybody, do not lose sight of what you're trying to achieve. Because I don't know if you notice, but we have sine squared over cosine squared. And one of our goals was to create a tangent squared right here. And do you see that sine squared over cosine squared? That's tangent squared. And then you still have this 1 minus cosine squared. And hopefully you remember identity, that sine squared plus cosine squared equals 1. So doesn't sine squared equal 1 minus cosine squared of theta? So now you can go and substitute sine squared of theta, and this answer matches what you got up there. So I know, like, watching me do this or seeing somebody show you what to do, you might think like, oh, okay, that makes sense. But I just feel like as long as you're not breaking rules and you're trying something, the intuition will build. Hopefully this helps you out. I'll see you when I do.